Over 100 million years ago, Earth was a world unrecognizable to us today. No humans walked its lands, no cities or roads disrupted the wild landscapes. Instead, colossal creatures roamed freely, dominating every ecosystem with unmatched power. These were the dinosaurs, some so immense they towered over the tallest buildings we know, their jaws capable of crushing bone in a single bite. Among them, certain species were astonishingly fast, able to outrun almost any threat. For more than 170 million years, these rulers of Earth shaped the planet's ecosystems, their reign virtually absolute. But then, in an instant of cosmic fate, everything changed. A cataclysmic event wiped these magnificent creatures from the face of the planet forever. What exactly happened? How did it unfold? This story invites you to journey back in time to witness it all. The term dinosaur itself carries a vivid meaning, derived from Greek, deinos, meaning terrifying, and sauros, meaning lizard. Together, it literally translates to terrible lizard. First coined by the English paleontologist Richard Owen in 1841, the name captured the fearsome presence of these creatures. Yet, when paleontologists discovered the earliest dinosaur fossils, they knew very little about them. Early illustrations, influenced by imagination more than evidence, portrayed dinosaurs in ways that today seem almost comical stiff, upright, and far from the dynamic animals we now understand them to be. One of the first recognized species, Megalosaurus, appeared in these early depictions, showing a creature far larger and more fearsome than anything living at the time. Over decades, as more fossils were unearthed and analyzed, these illustrations were gradually refined, bringing a new realism to the ancient world. To date, over 10,000 dinosaur fossils have been excavated worldwide, representing more than 900 distinct species. Between 2003 and 2022 alone, scientists identified an average of 45 new dinosaur species each year, a testament to how much we are still discovering. Consider, for instance, a bizarre dinosaur unearthed in Chile in 2021. It possessed a blade-like tail and a beak in place of a mouth, earning it the name Securer. Each new discovery adds depth to our understanding of these creatures, their diversity, and their dominance over prehistoric Earth. Imagine standing on that ancient land, hearing the distant roars, and sensing the shadow of a predator larger than any skyscraper. The Earth of that time was wild, untamed, and ruled by these astonishing animals. Through fossils and careful research, we can reconstruct this world piece by piece, yet it still retains an aura of mystery. How did these creatures evolve? What did their habitats look like? How did they interact with one another and with their environment? These questions set the stage for an epic journey into the age of dinosaurs. The story of dinosaurs begins roughly 230 to 240 million years ago, during the late Triassic period. At this time, Earth was a vastly different planet. All the continents we know today, Asia, Africa, Australia, Europe, and the Americas, were fused into a single massive supercontinent called Pangaea. The climate was harsh and arid, with limited rainfall, expansive deserts, and volatile weather patterns. This was a world that tested the resilience of every living creature. Among the earliest dinosaurs was Eoraptor, a small, nimble predator barely 2 meters long, yet vital to the evolutionary story of the dinosaurs. Despite its modest size, it represented the dawn of a lineage that would dominate Earth for millions of years. These early dinosaurs were nothing like the towering giants of the Jurassic or Cretaceous. They were light, agile, and highly adaptable, characteristics that allowed them to survive where many other species failed. Life during the Triassic wasn't dominated by dinosaurs. Instead, giant reptiles roamed the land, including enormous crocodile-like predators and early relatives of turtles. Many of these animals looked deceptively cute in comparison to later Jurassic giants, but they were formidable in their own right. The evolutionary landscape was competitive, pushing dinosaurs to innovate through speed, intelligence, and later, size. The geography of Pangaea created unique ecosystems. Vast deserts alternated with lush river valleys, volcanic plains, and scattered forests. The supercontinent's massive interior suffered from extreme heat during the day and frigid cold at night, forcing early animals to adapt. Dinosaurs, with their upright posture and advanced limb structure, were better suited to traverse these challenging terrains than most reptiles of the time. Fossil evidence tells us that these early dinosaurs weren't solitary wanderers. They likely lived in small social groups, hunting or foraging together to increase survival chances. Over time, these adaptations' lightweight bodies, strong hind limbs, sharp teeth, and keen senses set the stage for the rapid diversification that would follow in the Jurassic period. From the first Eoraptor to the many species evolving simultaneously across Pangaea, the Triassic marks a critical foundation in Earth's history. It was a period of experimentation, evolution, and survival under relentless pressure, a stage upon which the dinosaurs' story would soon explode into life. The seeds of dominance had been sown, but the world was about to test them in ways no species could have anticipated. While dinosaurs were beginning to emerge, Earth was undergoing dramatic and violent transformations. Around 201 million years ago, the late Triassic period drew to a close, bringing with it one of the planet's major mass extinctions. Vast volcanic eruptions erupted across what is now North America, releasing enormous quantities of carbon dioxide and sulfur dioxide into the atmosphere. These emissions caused sudden and severe climate changes in ocean chemistry shifted dramatically as CO2 and sulfuric compounds mixed with water, increasing acidity and devastating marine ecosystems. On land, temperatures fluctuated unpredictably, making life precarious for many cold-blooded reptiles, which relied on stable conditions to regulate their body heat. The majority of these creatures perished, leaving behind only those species with traits capable of weathering extreme changes. It was here that dinosaurs' evolutionary advantages became evident. Many early dinosaurs, unlike their cold-blooded counterparts, may have maintained higher metabolic rates, a precursor to warm-bloodedness. This allowed them to endure a wider range of temperatures and survive in fluctuating conditions. Small size, agility, and generalist diets further contributed to their resilience. Whereas many large reptiles could not cope, early dinosaurs adapted, endured, and diversified. Surviving species rapidly expanded into ecological niches left vacant by extinct creatures. Carnivorous early dinosaurs hunted small vertebrates, while herbivores began exploiting sparse vegetation. This period of survival and adaptation set the stage for the Jurassic era, a time when dinosaurs would rise to global dominance. Interestingly, the Triassic extinction was relatively gradual in geological terms. Although sudden from a human perspective, it unfolded over thousands to hundreds of thousands of years, giving the most adaptable species time to evolve and fill the voids left by the dead. These evolutionary experiments would pay off immensely in the next 150 million years when the dinosaurs' reign truly began. With the Triassic extinction behind them, dinosaurs entered the Jurassic period, roughly 201 to 145 million years ago, a time that would see their rise to undisputed dominance. Freed from the competition of many earlier reptiles, dinosaurs diversified rapidly, filling ecological niches across land, air, and indirectly water. The landscapes of Jurassic Earth were a patchwork of lush forests, fertile river valleys, and volcanic plains, all teeming with life. During this era, some dinosaurs grew to staggering sizes. Species like Megalosaurus were among the first large predators, possessing powerful jaws and muscular bodies capable of taking down smaller contemporaries. Meanwhile, immense herbivores such as Brontosaurus and Diplodocus roamed the plains, feeding on the abundant ferns, conifers, and cycads that dominated the flora. The sheer scale of these giants was breathtaking. Brontosaurus, for example, could reach lengths of over 20 meters, with tails that acted like whips for defense against predators. The Jurassic also witnessed evolutionary experimentation in locomotion and predation strategies. Some carnivores developed longer legs for speed, keen eyesight for hunting, and even evidence of pack behavior to increase hunting success. Herbivores evolved protective adaptations, from armored plates to intimidating spikes and tails, creating an ongoing evolutionary arms race that pushed species to greater extremes of size and specialization. Early bird-like dinosaurs began to appear, showcasing the evolutionary experiments that would eventually lead to flight. Feathered species like Archaeopteryx, discovered in late Jurassic strata, provide a glimpse of this transition. A fascinating blend of reptilian and avian traits, complete with wings and primitive feathers, hinting at a future where some dinosaurs would escape the terrestrial world entirely. In the oceans, giant marine reptiles dominated, from ichthyosaurs to plesiosaurs, while the skies saw the emergence of the first gliding reptiles. Together, these ecosystems formed a dynamic, interconnected web of life, with dinosaurs at the apex. The Jurassic period was not merely a chapter of growth, it was a period of experimentation, adaptation, and expansion that would define the age of dinosaurs for millions of years. By the late Jurassic, the evolutionary experiments that had begun on land extended into the skies. Some small feathered dinosaurs developed wings, not yet for sustained flight, but likely for gliding or balance while running. Among these early aviators was Archaeopteryx, often hailed as the first bird-like dinosaur. With its blend of feathers, wings, and teeth, it represented a critical link between traditional terrestrial dinosaurs and the birds we know today. Flight opened entirely new ecological opportunities. The ability to glide or fly allowed these dinosaurs to escape predators, exploit food sources high in the trees, and travel longer distances in search of suitable habitats. The skies became arenas of competition, where speed, agility, and keen vision determined survival. Even the smallest shifts in feather structure and wing shape had enormous consequences, gradually shaping more efficient flyers over millions of years. Meanwhile, land-based dinosaurs continued to dominate the terrestrial ecosystems. Herbivorous giants like Brachiosaurus and Diplodocus grazed the treetops, while predators honed their strategies to hunt with precision and coordination. The coexistence of airborne and terrestrial species created a complex, vibrant, and constantly evolving ecosystem. Interestingly, not all flying adaptations were about escape or predation. Feathers initially likely served purposes like insulation, display, or mating rituals, illustrating how evolutionary traits can be multifunctional. Over time, these features would be refined into true wings capable of powered flight. The experimentation of the Jurassic sky set the foundation for the eventual evolution of modern birds, ensuring that the legacy of dinosaurs would endure long after the mass extinction event. The skies of the Jurassic were a playground of evolution, where survival favored innovation. The emergence of flying dinosaurs marked a new chapter in the story of life, bridging the terrestrial dominance of the past with the aerial possibilities of the future. As the Jurassic period gave way to the Cretaceous, beginning around 145 million years ago, dinosaurs entered what many paleontologists consider their golden age. This era was defined by unparalleled diversity, massive size, and a rapidly changing world. The breakup of the supercontinent Pangaea into smaller landmasses Laurasia in the north and Gondwana in the south reshaped climates, created new coastlines, and opened countless ecological niches. The result was a flourishing of dinosaur species, each adapted to very specific environments. The Cretaceous also saw the rise of flowering plants, adding a new complexity to the ecosystems. Herbivorous dinosaurs now had a greater variety of food sources, from towering conifers to colorful angiosperms. These plants influenced not only diets but also behaviors, migration patterns, and predator-prey interactions. Dinosaurs like Iguanodon and Hadrosaurus thrived in these conditions, using specialized teeth and jaw structures to efficiently process tough vegetation. Predatory dinosaurs evolved in parallel, with apex hunters like Tyrannosaurus rex dominating the land. Measuring up to 12 meters long and equipped with jaws delivering unparalleled bite force, T-Rex exemplified the pinnacle of evolutionary adaptation. Alongside it, other formidable predators, Velociraptor, Spinosaurus, and Allosaurus developed hunting strategies ranging from stealth and speed to sheer strength, creating a tense and dynamic ecosystem where survival depended on intelligence, agility, and sometimes sheer luck. Size extremes were also a hallmark of the Cretaceous. Titanosaurians like Argentinosaurus could reach lengths of over 35 meters and weigh up to 77 tons, dominating their environments simply by mass. In contrast, smaller species evolved with remarkable speed, cleverness, or defensive adaptations like armor and spikes, ensuring that even the tiniest dinosaurs played crucial ecological roles. The oceans teemed with life as well. Mosasaurs, giant plesiosaurs, and early sharks patrolled the waters, while pterosaurs soared above, some boasting wingspans exceeding 10 meters. The aerial and aquatic ecosystems mirrored the land, offering a full spectrum of predator-prey interactions and evolutionary innovation. The Cretaceous was a period of vibrant ecosystems, evolutionary experimentation, and dominance, setting the stage for the dramatic end-of-era event that would forever alter life on Earth. During the Cretaceous, dinosaurs reached the peak of their evolutionary diversity and ecological dominance. This period produced some of the most iconic species in paleontological history. The mighty Tyrannosaurus rex, with its massive jaw and unparalleled predatory skills, ruled as the apex predator of its environment. Its hunting techniques, social behaviors, and interactions with prey reveal a sophisticated understanding of survival and territory, illustrating evolution at its finest. Among herbivores, the giant titanosaurs like Argentinosaurus and Patagodon grew to astonishing sizes, weighing tens of tons and stretching tens of meters in length. These gentle giants shaped the landscapes they roamed, consuming enormous amounts of vegetation daily and influencing the growth and distribution of plant life. Armored dinosaurs, including Ankylosaurus and Nodosaurs, evolved heavy plates, spikes, and clubbed tails as defenses against predators, turning their bodies into formidable living fortresses. Speed and agility were just as important for survival. Dinosaurs such as Onychomymus, reminiscent of modern ostriches, could sprint at incredible speeds of up to 80 kilometers per hour, evading predators or chasing prey with remarkable efficiency. The skies were ruled by pterosaurs like Quetzalcoatlus, the largest known flying creature, with wingspans up to 10 to 11 meters, showing that evolutionary pressures were not confined to land. Dietary specialization was another hallmark of the Cretaceous. Some species evolved crushing teeth to feed on hard-shelled prey, while others developed beaks for selective browsing or slicing foliage. This specialization led to complex ecosystems where every niche, from predator to scavenger to herbivore, was finely tuned. Even the smallest creatures, such as early mammals and birds, adapted to survive alongside giants, laying the foundation for post-dinosaur ecosystems. The Cretaceous period stands as a testament to the zenith of dinosaur evolution, a world of extraordinary forms, sizes, and behaviors. Dinosaurs dominated every ecological niche from the ocean floor to the treetops and across vast continents, illustrating both the power and vulnerability of life shaped by millions of years of evolution. All this dominance came to a sudden and catastrophic end about 66 million years ago, marking the close of the Cretaceous period. The culprit was a massive asteroid, estimated to be 10 to 15 kilometers in diameter, striking what is now the Yucatan Peninsula in Mexico. Traveling at a staggering speed of 30 kilometers per second, over 150 times faster than a commercial jet, the impact released energy equivalent to roughly 100 teratons of TNT, an unimaginable force that instantly reshaped the environment. The collision created a crater approximately 180 kilometers wide, unleashing heat, shockwaves, and earthquakes across the globe. Massive amounts of rock and debris were ejected into the atmosphere, igniting wildfires and sending incandescent material raining down for hundreds of kilometers. The immediate thermal radiation likely cooked living creatures in the vicinity, while tsunamis of unprecedented scale swept across coastlines. But the short-term destruction was only the beginning. Dust and aerosols thrown into the atmosphere blocked sunlight, plunging Earth into a nuclear winter that lasted for years. Photosynthesis ceased, plants died, and herbivorous dinosaurs starved, triggering a cascading extinction throughout the food chain. Carnivores, deprived of prey, soon followed. It is estimated that over 75% of species on Earth perished in this event, including virtually all non-avian dinosaurs. Some small animals survived by hiding underground, in burrows, or underwater. Early mammals, small reptiles, and certain birds endured, feeding on detritus, fungi, or decaying matter. These survivors formed the seed population from which mammals would later diversify, eventually leading to the rise of humans. This extinction, known as the KPG, Cretaceous Paleogene event, serves as a stark reminder of the fragility of life, even for species that seemed invincible for millions of years. It reshaped the Earth, setting the stage for new evolutionary opportunities and opening ecological niches that would be filled by mammals and birds, the heirs to the world once ruled by dinosaurs. In the wake of the KPG extinction, Earth entered a transformative period known as the Paleogene. The disappearance of non-avian dinosaurs left vast ecological gaps. Forests began to recover, Flowering plants expanded dramatically, and the climate gradually stabilized. Small mammals, which had survived by staying hidden and opportunistic, began to diversify, exploiting niches left vacant by the giants that had perished. Early ancestors of horses, primates, and even elephants began to evolve during this time, slowly laying the groundwork for modern ecosystems. Interestingly, not all dinosaurs were lost. Birds' descendants of small, feathered theropods persisted and flourished. They adapted to a wide range of habitats, evolving into the incredible diversity of avian species we see today. In a sense, dinosaurs never completely vanished. Their lineage lives on in the skies, continuing a story that began over 230 million years ago. The post-extinction world was harsh, yet full of opportunity. Volcanic activity, shifting continents, and climate change continued to reshape the land. Yet, in this turbulence, new life thrived. Mammals grew in size and complexity, some eventually dominating the land in ways dinosaurs never could. The legacy of the dinosaurs' reign was evident in these new forms, which inherited not only ecosystems shaped by giant herbivores and apex predators, but also evolutionary lessons about adaptation, survival, and resilience. Studying this period provides critical insights into how life recovers from catastrophic events. It also offers cautionary lessons about vulnerability, demonstrating how quickly dominant species can vanish under extreme conditions, no matter how powerful they seem. The extinction of the dinosaurs paved the way for mammals, birds, and eventually humans, setting the stage for the remarkable biodiversity we experience today. Though non-avian dinosaurs vanished, their legacy continues to fascinate scientists and the public alike. Fossils discovered across every continent tell stories of an ancient world filled with incredible diversity, from towering sauropods to fleet-footed raptors. These discoveries help us reconstruct ecosystems, understand evolutionary trends, and appreciate the sheer scale of time over which life on Earth has evolved. Dinosaurs shaped Earth in ways that persist long after their extinction. Their feeding habits influenced plant distribution and evolution. Their movement patterns shaped sediment and landscape structures. Even today, studying dinosaur anatomy inspires innovations in robotics, biomechanics, and engineering, revealing how evolution solves complex problems of movement, balance, and survival. Modern birds represent the direct continuation of the dinosaur lineage. Every feathered creature in the sky, from the smallest hummingbird to the largest flightless ostrich, carries a biological history stretching back to the Mesozoic. Understanding this connection offers profound insight into how traits like feathers, flight, and metabolic adaptations evolved over millions of years. The fascination with dinosaurs also permeates culture and imagination. From scientific documentaries to blockbuster films, these ancient creatures captivate the human mind, reminding us of a world both alien and magnificent. Through museums, movies, and literature, dinosaurs inspire curiosity, creativity, and scientific inquiry, ensuring their presence endures far beyond the fossil record. Dinosaurs teach us about survival, adaptation, and the transient nature of dominance. They remind us that even the mightiest species can vanish in the blink of a geological eye, but their legacy can influence life on Earth for millions of years to come. In studying them, we also learn about ourselves, the fragility of life, and the resilience that allows life to persist in the face of catastrophe. To put the scale of dinosaur history into perspective, humans have existed for a mere instant compared to the age of dinosaurs. Non-avian dinosaurs ruled Earth for approximately 174 million years, while modern humans have only been around for roughly 300,000 years, a fraction of a percent of that time. The contrast is staggering. The creatures that once dominated continents, seas, and skies did so for over 500 times longer than our species has existed. This perspective emphasizes both the longevity and vulnerability of life. Dinosaurs flourished because they were highly adaptable, yet they could not survive a sudden catastrophic impact. Humans, with advanced technology and civilization, have the power to alter the environment, intentionally or unintentionally, at a speed that rivals natural disasters. The comparison highlights the importance of stewardship, scientific understanding, and preparation against potential global threats, such as asteroid impacts or climate change. Remarkably, the study of dinosaurs has influenced how we view our own evolution. Fossil evidence, genetic studies, and paleontological research reveal patterns of adaptation, extinction, and resilience. By understanding how dinosaurs and other prehistoric life responded to environmental changes, we gain insights into modern ecosystems, conservation efforts, and the potential consequences of rapid ecological disruption caused by humans. Dinosaurs remind us that no species, no matter how dominant, is invincible. Humanity's brief tenure on Earth offers both opportunity and responsibility to learn from the past, protect biodiversity, and ensure that our presence contributes positively to the planet rather than leading to self-induced catastrophe. In this light, the story of dinosaurs is not just ancient history, it is a cautionary tale for the present and future. While dinosaurs perished due to a catastrophic asteroid impact, modern species, including humans, face threats primarily from human activity. Scientists often describe this as the sixth mass extinction, driven by habitat destruction, pollution, climate change, and overexploitation of natural resources. Over the past century, countless species of mammals, birds, reptiles, amphibians, and insects have declined rapidly, many teetering on the brink of extinction. Deforestation, urban expansion, and industrial agriculture have fragmented habitats, leaving wildlife vulnerable. Oceans, once teeming with life, are now affected by pollution, overfishing, and acidification. Species that once thrived in diverse ecosystems are now confined to shrinking patches of land or protected reserves. In some cases, extinction occurs faster than scientists can document, erasing genetic and ecological diversity forever. The speed of current extinction is alarming. Estimates suggest that species are disappearing 100 to 1,000 times faster than natural background rates. Unlike the asteroid that wiped out the dinosaurs, these losses are largely preventable. Conservation programs, legal protections, and international agreements aim to slow or reverse biodiversity loss, emphasizing the importance of proactive action. Efforts, such as the 2010 UN Convention on Biological Diversity and subsequent initiatives, set measurable goals to protect ecosystems, reduce pollution, and conserve at least 30% of terrestrial and marine habitats by 2030. The survival of countless species, and potentially human civilization itself, depends on our ability to respond effectively. The lesson from the dinosaurs is clear. Even dominant, well-adapted species can disappear rapidly when the environment changes beyond their capacity to adapt. While human activity threatens biodiversity on Earth, cosmic hazards remain a persistent risk. Asteroids and near-Earth objects, NEOs, have the potential to cause catastrophic damage, much like the asteroid that ended the reign of the non-avian dinosaurs 66 million years ago. Scientists continuously track these celestial bodies to predict potential collisions and implement defensive strategies. NASA and international space agencies monitor tens of thousands of NEOs, identifying more than 28,000 as of 2022, with hundreds large enough to cause global consequences if they were to strike Earth. Predictive modeling allows scientists to calculate trajectories and assess probabilities, enabling early warning systems that could provide decades of preparation for potentially hazardous objects. In 2021, NASA launched the Double Asteroid Redirection Test (DART) mission to explore the feasibility of altering an asteroid's trajectory. By deliberately colliding a spacecraft with an asteroid in a controlled experiment, scientists demonstrated that it is possible to shift an object's path, a critical proof of concept for future planetary defense. This technology could allow humanity to prevent a global extinction event similar to that of the dinosaurs. While the odds of a catastrophic impact are low in any given year, the consequences would be severe. Understanding, preparing for, and mitigating these cosmic threats is essential. Humanity has the unprecedented ability to anticipate dangers and act in ways that no species, including dinosaurs, could, highlighting both our vulnerability and our extraordinary capacity for problem-solving and survival. The story of dinosaurs is more than a chronicle of ancient life. It is a lesson in adaptation, resilience, and the consequences of sudden environmental change. Dinosaurs evolved over millions of years to become the dominant terrestrial, aerial, and even aquatic creatures, yet a single catastrophic event abruptly ended their reign. This illustrates the delicate balance between biological success and environmental vulnerability. For humans, this story carries a powerful message. Our technological prowess and civilization give us unprecedented control over the environment, yet our actions, Deforestation, pollution, climate change can trigger rapid ecological shifts with far-reaching consequences. In essence, humans now face both natural and self-imposed threats that could rival the asteroid that ended the dinosaurs. Studying the fossil record, ancient climates, and extinction events allows scientists to predict potential risks and guide conservation efforts. It highlights the interconnectedness of species, ecosystems, and the planet. Every action, from protecting habitats to reducing greenhouse gas emissions, has the potential to influence the future survival of countless species, including humans. The dinosaurs also remind us of evolutionary creativity. Feathers, flight, gigantism, and sophisticated hunting strategies showcase how life adapts to challenges over time. Yet, the abruptness of extinction underscores that no adaptation guarantees survival against rapid or extreme changes. By reflecting on their history, humanity gains insight into the importance of foresight, innovation, and stewardship of the planet. Even millions of years after their extinction, dinosaurs continue to shape our world. Fossil discoveries expand our understanding of life's history and inspire scientific inquiry, education, and imagination. Museums around the globe preserve skeletons and fossils, bringing ancient ecosystems to life for new generations. Paleontology not only reveals the past but also informs modern biology, ecology, and evolutionary science. Dinosaurs influence modern culture profoundly. From blockbuster movies to books, video games, and art, they captivate the imagination, symbolizing both awe and danger. Their forms inspire robotics, biomechanics research, and even architectural design, demonstrating that ancient life can guide contemporary innovation. Scientifically, studying dinosaurs illuminates the evolutionary links between extinct species and modern animals. Birds, as direct descendants of small theropods, are living dinosaurs, offering clues about flight, metabolism, reproduction, and behavior. Observing them today provides a window into the lives of creatures that roamed Earth millions of years ago. The story of dinosaurs also serves as a benchmark for understanding extinction, resilience, and survival. By learning from past events, asteroid impacts, climate shifts, and mass extinctions, we gain perspective on modern challenges, from human-driven biodiversity loss to planetary defense against cosmic hazards. Dinosaurs remind us that dominance is temporary, survival requires adaptability, and life continually evolves in response to environmental pressures. Ultimately, the dinosaurs' legacy is both cautionary and inspiring. Their rise, reign, and sudden disappearance highlight the fragility of life, the power of adaptation, and the extraordinary creativity of evolution. In studying them, humans are not only exploring the past, they are preparing for the future, understanding the delicate balance of life and ensuring that we too can endure in a changing world.